Hello, good day once again, and welcome to my channel. Today I'll be discussing about modeling data in the organization. Okay, so for today we're going to cover a lot of objectives, but just so we'll be guided for today's lesson. So we'll just do some definition of terms, the importance actually of data modeling in databases, writing good names and definitions, distinguish unary, binary, and ternary relationships, model different types of attributes, entities, relationships, and cardinalities. We draw ER diagrams for common business situations, and we'll try to convert many-to-many relationship into associative entities. And we will also apply model time-dependent data using timestamps. When we talk about building a data model within the organization, we have to consider the business rules because, as you all know, the business rules plays a very important role in identifying the relationship of how the data is moving within the organization together with the processes. So one of the business rules that we have to consider would be in terms of how you go about with the purchasing process within the organization. So all those kind of stuff. Now, when we talk about business rules, these are statements that define or constrain some aspects of the business. So just like what I said, this could be processes within the organization. So they assert business structure. So they also follow the line of command or the organizational structure of the employees. So to speak, there's actually a hierarchy in terms of control and the processing of a lot of things within the organization. Yes, control or influence business behavior. We express this in terms of familiar rather to end users, so that it would be easy for them to understand. And of course, we automate this one through DBMS software later on. Now, talking about a good business rule, it has to be declarative, precise, atomic, consistent, expressible, distinct, and business oriented. These terms are actually just a guide for us, so I don't have to discuss each item. I believe these things are very self-explanatory. Identifying also data names for the terms that we're going to use eventually in the ER diagram and the data that we are going to collect. We have to consider also something that is related to business and are not technical. And it should be meaningful and self-documenting at the same time. So let's say, for example, in various organizations, some would say SKU, inventory, or stocks, or unit. So these terms actually differ across different organizations, but we have to identify since we are dealing with an actual organization as well. It has to be unique and readable. And normally there should be a list from this one, but we don't have to go over that one. And it could be repeatable as well. When it comes to data definitions, we want to explain to you what we call a term. So yeah, when we say term, it's a word or phrase. And a good example would this be on that one on screen: course, rental, car, section, flight, and so on. And then when we say a fact, it could be now as an association between two or more terms. So we are trying to build something out of the different terms. So a course is a module of instruction in a particular subject area. When it comes to data definitions, we have also certain guidelines for that one. So in here, what I have is only I have here your list. These are gathered in conjunction with systems requirements. So at the very beginning of the software development, we have to do systems analysis and requirements. So we have to identify this at the very first. So this is part of what eventually will be our output in terms of system requirements. These are accompanied by diagrams. So we have flow charting, ER diagrams, data flow diagrams as well. Yes, we create this iteratively because in one setting it's not going to be correct or perfect. So it has to be done iteratively to make sure everything is being captured. And it has to be achieved by consensus. So because there is no perfect system, So we have to consider uh, every member of the team. Is this okay? Is this good enough for you? And so on. This time we go to the ER model, or the entity relationship model. This is yet an overview. But when we talk about an ER model, take note of this one. It is a logical representation of the data for an organization or for a business area, using entities for categories of data and relationships for associations between entities. It might be very vague for some, but don't worry, we'll get to know a little deeper on this one. Now, when we say ERD, this adds the word diagram already. So entity relationship diagram. This time, this is what we call the graphical representation of an entity relationship model, and this is what we will be building later on. The most important thing that we have to understand is the model constructs of an entity relationship model. So we have the words entities. Now, what are entities? So when we say entities, this could be a place, person, object, concept, event in the user environment, okay, by which the organization wishes to maintain data. So I think I have given you some scenario early on. Let's say, for example, your kiosk. So that is actually a good example, a small business to start. Now, moving on, we have here entity instance. Entity instance, this could be a person, place, object. So this often corresponds to a row in a table. Now, I have mentioned this before in the previous lectures that a row could mean a record or a tuple, right? So you have to take note of that one. Entity type, collection of entities, often corresponds to a table. So this is one of the things that you get to know a little bit deeper as we move along. Here are some examples of some entities. So when it's a person, this could be an employee, student, patient, place, object, and many more. What I have here is an example of an employee entity, although it is arranged quite differently. So don't worry about it, because the way it is being arranged, the row is being created as a column, so it should not be the case. But nevertheless, just to give you the idea of what an entity is, in this case we have an employee entity. So the contents of of an entity would be the attributes. So you have your attributes. These attributes must only be specific to that particular entity. Okay, now you have the corresponding data type for each attribute, and the one on the third and fourth columns, that would be the example value. Now, talking about ER model constructs, we have to consider relationships. Like I said, this is not about relationship about, boy-girl relationship. This is about relationship in terms of the entities within the organization, or the data that is being collected within the organization. So when we have relationship instance, this means that this is a link between entities, which corresponds to the primary key, foreign key equivalent in related tables. And you have also your relationship type, so which we will also be identifying later on. Then the important thing is, when you have the word attribute, it simply mean what? It says here a property or characteristic of an entity or relationship type. So this often corresponds to a field in a table. So it's not really that difficult to learn database stuff. Now what you're seeing here is an example of an ER diagram. Oh, don't be scared, please. You'll get to know each item, how to do those things later on. Okay. Now, if you're going to look at this one, there's the legend at the bottom. So the one in rectangle are what you call entity types. Then the lines would be your relationship. How is it related to the other entities? So this actually describes the relationship together with the cardinalities, the one you see in the lower right. So for each entity, there's actually a relationship that is considered. between the two entities together. So it could be a mandatory one, optional one, mandatory many, or optional many. So if you're going to look at, let's just take a look at the customer and the order entities at the upper right. Now, in this case, a customer can submit zero or many order. So you as a customer, you are not required to order, right? So you are still considered as a customer even if you did not purchase anything, because you're doing a window shopping, so you are considered a customer. But in terms of capturing data, you are not required. Just because you're inside a store, you're not required to purchase. So that's going to be an optional. Purchasing something is not a requirement, but it's an optional thing within the business. So it's submitted by a customer. So zero. A customer can submit zero or many orders. On the other hand, if you're going to, the way you read it is actually from left to right and then right to left. So customer can submit zero or many orders. Then the corresponding order is actually owned by a one and only customer. So you don't see a customer, or I mean, an order rather, that is owned by multiple customers, right? So that is how entities and relationship go together. I hope you are able to capture that one. Hey, are you still with me? Okay, so I'll continue. Now what you see on screen now is an ER notation. So the ER notation actually tells you a lot of things. Now this is actually your guide in building your ER diagram, so don't freak out. Now you can see there the entity types. So these are the boxes wherein you place the entities. This could be translated later on to a table when you will be building your actual database. Now you also have the attributes. So now there are different options in terms of how you draw your ER diagram, but the way these diagrams are represented right now is the way I want you to do it as well. Okay, because there are those there's a what do you call this? There are other models that you can follow, but I recommend this type. So you see the attributes is also inside a box, then the entity name is there, and then the corresponding attributes. Now please make sure to underline the primary key, and if ever you have a foreign key, you can actually broken underline. Yes, you can do that one. So you have different relationship degrees there, unary, binary. You also have ternary. And again, the relationship cardinality is also presented below. You might be wondering, how will you know the relationship between the entities? You will actually know that one base. If you have no, if you do not have any idea, you can base it on actual scenarios, just like what I have mentioned earlier between the customers and orders. Now, it's going to be a common practice that you as a customer, you're not required to purchase anything, right? So in that case though, since it says the event rather that was being used as an entity is the order. So this means that this is actually an online or an e-commerce website. So in that case, it is identified that it is not required. So you as a customer, it's not required for you to submit an order, right? So in that case, you will be able to know, or you can translate that one into a cardinality. So a customer is not required to order. So you can have zero or many orders. Okay, here just a further emphasis on the symbols. So entity symbols, attribute symbols, then relationship symbols. So please don't forget this one because you will be using this one in your ER diagram. So Relationship cardinalities specify how many of each entity type is allowed. So that's that example I have mentioned earlier. And then a special entry that is also a special entity type rather, as called associative, that could also be part of the relationship later on. Now you might be wondering, how would you be able to come up with an entity? Here's a guide for you. It should be an object that will have many instances in the database. And it is an object that will be composed of multiple attributes and an object that you are trying to model. Okay, so in the organization, there will be a lot of data involved. So you have to identify which one. It should not be a user of the database system or an output of the system. For this particular slide, this just illustrates an example of an inappropriate entities. So you have your treasurer, expense report, account, and expense. Now, a treasurer need not to report a treasurer rather is a system user, so it's not ideal that a system output should also be there. Between the treasurer, it could be referred to as an employee, you know, so or it could simply be account is charged with expense. That would be the appropriate entities. It doesn't need those two at the top. When it comes to attributes, again, as I mentioned earlier, it is a property or characteristics of an entity or relationship type. You might be wondering why relationship type. You will know that later on. Now, there are different classification of attributes. There are those that are required versus the optional. You have your simple versus the composite. You have your single valued versus multi-valued, and stored versus derived attributes. And of course, your identifier attributes. Here is an example of an entity type for a student. So as you can see there, the attributes are all related to the personal information of the student. So each attribute has a corresponding attribute data type, and you will notice there it's either required or optional. So among all others, major is actually optional. Now an example instance, you can see there, and the last column as well. Now what about composite attributes? Composite attributes are those attributes that has a meaningful component parts. So when we talk about employee address, this could mean it is a composition of a street address, city, state, postal code. So that's what you call composite. Now, when you say about simple or atomic, those are actually the individual components already. So in the case of the employee address, your street address is already very specific. Your city, you cannot break it further. So that's why you call them simple or atomic. Another classification of an attribute would be multivalued attribute or a derived attribute. Now, multivalued attribute could mean simply when a field can take in more than one value. So just like your skills, what are your skills as of now? So you will be a future accountant, so you should have analytical skills, okay? Auditing skills, accounting skills. I think those are considered skills. Then you also have the derived attribute. Now, the derived attribute is something that is computed, of course. And in the example here, we have years employed, and it should be based on what? The computation or for years employed will be based on the day you were employed. Now you have identifiers. Now these are your primary keys and foreign keys. Identifier, it says here, it is an attribute or a combination of attributes that uniquely identifies individual instances of an entity type. Now, the individual instances represents your individual record in your table. So each record must be identified with a primary key. Now, there are those keys that are considered simple and there are those that are considered composite. Now, when you talk about composite, it could be a combination of one or two fields. When you say simple, it's just a simple field, but in your case, your student ID is actually a composition of several other values. So if you were enrolled 19, your ID numbers, your student ID number starts with 19. That is the year that you came to Silliman or you were enrolled to Silliman. Dash, the 1 represents the semester that you were enrolled. So if you are 3, that means you were enrolled during the summer term. And then the last digit, 4, 5 digits, that represents in terms of on what or how many enrollees, that represent the number. You are the, let's say, 400th student enrolled during that semester. Now we have also what we call the candidate identifier. These are attributes that can be considered also as key because they satisfies the requirement for being an identifier that is unique. So in this case, you will have, for example, driver's license, UMID ID number, your TIN. So those are actually unique numbers, and they are very important. So they can represent also as an identifier. Let's go. I just want to go through with this one, characteristics of identifiers. It will not change in value. It should not be. It will not be null. No intelligent parameters. You have to substitute new or simple keys for long and composite keys. Now the change in value, so let's say for example, especially for girls, now when you come back to Silliman right after graduation and you study MBA or whatever course you want to enroll in, your ID number will still be the same. Okay, so because that's the same person. If you got married, for example, you have the change in last name, then what will be updated would be your record only, but the ID number will stay the same. Now we have simple identifier and composite identifier. So this is just an example here. So when you have a student ID would be unique and a simple identifier. A composite, let's say a flight ID could be composed of a flight number, date, and number of passengers. So now we go to modeling relationships. Relationships are the glue that holds together the various components of an ER model. So it's very important because this is the one that associates the representation of each interaction among the various entities within the organization, wherein the data is actually of interest to them. The relationships and their characteristics, the degree and cardinality, represent the business rules. All right, for this particular slide, so please bear with me. I hope you're not sleepy and stay awake, please. Now, understanding relationships. Now, in this case, for example, in this particular example, these are employees of, let's say, a software development company. Now, they have the employees and the corresponding course. Now, each employee is entitled to study a particular course. The ones on the course column, those are actually programming languages. So each employee can be enrolled to any of those courses. Now, if you go back to the top between employee and course, an employee can complete many courses, and a course can also be completed by many employees. So as you can see, there's actually a many-to-many relationship, and each colored line below represents one record. So Chen here it completes C++, completes Java, Melton completes C++, COBOL, Perl, and so on. So this is actually very important. So you have to understand the relationship between these two entities. Okay, moving forward, let's talk about relationship type. So as you can see, between this, the slide before this one, you have seen the employee and the corresponding course. Now, I believe you can now imagine what is the relationship between the two entities, considering that they are working for a software development company. So when we talk about relationship type, this is your meaningful association between or among entity types. So this implies that the relationship allows us to answer questions that could not be answered given only the entity types. So that's why we have to relate the two of them. So as you can see in the previous slide, you are able to relate these two entities because an employee can actually enroll in a course, and a course can be completed by one or many employees. So we were talking about relationship type. Now this time we talk about relationship instance. In this case, relationship instance talks about the corresponding instances of every entity and every employee and course. If you notice the lines that you have seen earlier in the previous slide, those are what we call instances, meaning the relationship instance here corresponds to a particular record. So in this case, an employee completes C++, an employee completes Java. Those are relationship instance. So an association between or among entity instances where each relationship instance associates exactly one entity instance from each participating entity type. So this is what I have talked about on relationship instance. So as you can see there, the employee name and the corresponding course title. So those are the instances between the two entities. Now, if you notice on this table, it represented also a new field rather, that is date completed. Because if you notice, only having two entities, it would be very incomplete without considering the date of completion when Chen, Melton, or any of the employees completed a particular course. So it is a good record or a good data to be stored, considering that date completed corresponds to the date of completion for each course that they have taken. Okay? So that is something that you have to consider also when you will be building your own ERD later on. The attributes on relationships. So for example, suppose that the organization wishes to record the month and year. So this is in relation to the previous table that you have seen earlier. So this is when an employee completes each course. So meaning to say it has to be recorded, right, to a certain extent. This attribute would be named date completed. Now my question is, where should the attribute date completed be placed on the ER diagram? So this was the ER diagram earlier. Now as you can see, there are only two entities involved. Where do you think you would place date completed? So if you notice, this is one of the scenarios wherein you have to understand the relationship type between the two entities. Now, if you notice that an employee can actually complete one or many courses, and on the other hand, a course can be completed by one or many employee. So you can actually see that there's a many-to-many relationship. In this case, when you have a many-to-many relationship, you need to create a new entity, and that is what you call the associative entity. Now, going back to the question, where should the attribute date completed be placed on the ER diagram? Now, we can have a place for it. So this time, you might be asking, when are you going to create an associative entity? You are going to create an associative entity when you have a many-to-many relationship between two entity types. In this case, we can actually create an associative entity on the middle between the two entity types. The purpose of the associative entity is actually to break the many-to-many relationship. That's in the simplest term. So because we cannot manage a many-to-many relationship, if it's going to be represented in a table later on. At this point, our associative entity is now well represented. We now have drawn the actual associative entity. The symbol for associative entity is actually a rectangle with rounded corners. Now you might be wondering what is now the purpose of this one, considering that we have now an associative entity in between. Now we want to capture, remember, we want to take note. Just imagine this one. Where will you place the certificate number and the date completed? Or even just the date completed. You cannot place a date completed in the course because the course contains only any field that is related to the course. Remember, the date completed may be related to the course, but at the same time is also related to the employee. But you cannot place it also in the employee entity because the date completed is somewhat related to the course. So in this case, we create an associative entity and place the date completed in between. And yes, but we're not yet done. Okay. Now, how will you know that this particular certificate belongs to that particular employee and he has completed a particular course? That is where your foreign keys come in. So your employee ID from the employee entity and your course ID from the course entity will go to your certificate associative entity. So that fields that will serve now as foreign keys coming from the entity types. So you not only that you will have your certificate number, you will have date completed, you will have the employee ID so that we will know which this certificate belongs to, and we will also have the course ID to determine which course he or she has completed. Now, the second diagram below is actually the actual Visio representation, the Microsoft Visio, the software that is being used to create the ER diagram. Just to elaborate a little further on the associative entity, so this would be an entity type that associates the instances of one or more entity types and contains attributes that are peculiar to the relationship between those entities. So now, just like what you have asked probably or wondered earlier, how do you know whether to convert a relationship to an associative entity type? So here are some of the conditions that should exist. First, all the relationships for the participating entity types are many relationships. There's a many-to-many relationship. Second, the resulting associative entity type has independent meaning to end users and preferably can be identified with a single attribute identifier. Now, the single attribute identifier refers to the primary key so that we can really identify that particular record in that associative entity. The third one, it has one or more attributes in addition to the identifier. You cannot have an associative entity that only the primary key is existent. There should be other fields that goes with it. Fourth, the associative entity participates in one or more relationships independent of the entities related in the associated relationship. Now, this sentence might be confusing to you, but just imagine, try to go back to the one that we had earlier. Employee and course. Okay. Now that particular attribute on date completed cannot be placed in an entity, employee entity and the course entity. And that is where they are placed in the associative entity. This time we are talking about the degree of relationship. So the degree of a relationship is the number of entity types participating in that relationship. Now, the three most common degrees here are unary, binary, and ternary. Although higher degree relationships are possible, but they are seldom used in practice. So here you can see some examples on the relationships. You have unary. So you only have one entity for unary, but it refers back to itself. So for example, an employee is managing an employee. So one of the employees is actually a manager and the rest are actually frontliners or cashiers or waiters. So that's the kind of representation for a unary relationship. Binary, which is actually the most common one, you normally have two entities involved, so it's pretty much common. Ternary are actually, you can seldom see this one, and when this happens, you have to carefully evaluate whether this is needed or not. Because if you can make it into binary relationship, that would make it easier. Okay, so it doesn't confuse you also when you translate this one into the actual tables later on. So we'll just run through this one quickly. Unary relationship here, as defined, is a relationship between the instances of a single entity type. So they are referred normally as recursive relationships. The binary relationship contains two entity types, and like I said, this is the most common type of relationship encountered in data. Here's an example of bill of material structure. So it is trying to emphasize or illustrate rather in terms of that relationship that has been mentioned earlier. So these are basically examples. So the many-to-many relationship, the two-item bill of material structure. So those are actually examples wherein you can illustrate in terms of how those relationships can be done. Okay. So talking about ternary relationship, this is the simultaneous relationship among the instances of three entity types. Here is an illustration of a ternary relationship. So you must carefully evaluate ternary relationships so that it would not be very difficult for you to implement later on in terms of your application as well as in your database. All right, so I hope you did learn something today, and if you did learn something today, I want you to give me these questions. Give me an example of an entity. Give me an example of an attribute. Give me an example of an identifier. Now, how do you answer this one? You send me a private message on your answers in Zoom. Okay? Pause this video and then answer right away in Zoom. I'll wait for it. I'll wait for it. I'll wait for it. All right? Up next is cardinality. So cardinality is something that you must also understand. So as you can see in this slide, you see a movie stuck as DVD, although that's a little bit old already, if you know what I mean. But of course, DVD are still here, but it's no longer the most popular thing. What we have now is internet and streaming and Netflix. You know what I mean. Now, just imagine in this case, we are trying to illustrate cardinality in its simplest terms. Okay. Now, for this particular illustration, you can see the movie as one of the entity and the DVD as the another entity. So we can represent a movie which is stacked as DVD. I'm not sure if some of you here can still remember Video City, but yeah, you can imagine this as a Video City situation wherein a movie is actually stuck as a DVD, or it could be a VCD as well. You know what I mean, right? Now, a movie can have a minimum of 0 or a maximum of many DVD copies, right? Now, a DVD can only have a minimum of one movie and a maximum of one movie. Okay? Now, take note here that we are talking about the original copies of DVD, not the pirated ones, all right? So, bear with me here. So, in normal circumstances, take note that a DVD can only contain one movie. Okay? That's the normal one. So I hope you're able to imagine the cardinality in terms of its representation in the various entities. So once again, we have the ER notation representation. So please take note of this one. You really need to master this also over time. So just go back to this one. So as you can see at the bottom, that's where your relationship type. So that is how it is being represented. So it's very important that you also take note of that one. Okay. Now talking about cardinality constraints. So this is a rule that specifies the number of instances of one entity that can or must be associated with each instance of another entity. Let's take a look. Now, if you have seen earlier, this is the slide that I have shown you, and the movie here is stacked as DVD. So you can only be, or you might be wondering, sir, when can the constraint arise, or when does this happen? So you have to understand again the process of how the data is represented in the organization. How is it being utilized? What is the proper way? So probably in that particular business, since they are into, you know, movie rental perhaps, their DVD can contain not just one, but a minimum of 5 movies in one DVD. So that would basically be the basis of your constraints. So understanding the process, understanding basically the organization is one of the very first things, and it would help you a lot. So the minimum and maximum cardinality. Now talking about the minimum is this is the number of instances, the minimum number of instances of one entity that may be associated with each instance of another entity. I think you get the idea already on this one. If you're not, try to read it a little bit slow and try to absorb the concept of it. Okay. Maximum cardinality is the number of instances of one entity that may be associated with each instance of another entity. So just imagine a, a bicycle can only have one rider, right? So there's only one. A car can only have one driver. So that's where you can imagine cardinalities. So here are some examples of cardinality constraints. A patient has recorded patient history. So a patient can have a mandatory patient history every time a patient visits his or her doctor, and one patient history which should always correspond to at least one and only one patient. Second, an employee can have 0 or many projects. So in an organization, you could be part of a project, you may not be part of a project. However, a project must always have at least one employee or many employees. So don't forget, left to right, right to left. Of course, a person is married to another person. So that would be another example of a cardinality constraint. Okay, so for today, I will not give you a sit work, but in the next slide, that would be your assignment. Okay? So in this case, I want you to imagine and identify the possible entities, attributes, and relationships for the following type of business: a restaurant, or a DVD or a VCD movie rental store. You just choose one of these, okay? And don't forget to send it on SOL. It should be in a document format. So if you have access to a Visio or an online tool, please do make use of it so that it would be easier for you to draw at least these things. If you want to relate it already, you want to draw the relationship, a simple ER diagram, you can go for it. But it's really okay if you just list them down. List the entities, list the attributes for that particular entity, and all of those, okay? So our primary reference would be on modern database management. I have not yet uploaded this in our resource repository, but I will have this ready for you hopefully by next meeting. All right, so that would be our lesson on data modeling. We'll have more into this one in the next chapter, which is about logical database design. So it's very important that you have understood this particular chapter. If you have any questions, please do not be shy to ask. You can PM me in Zoom, you can send me an email, or you can actually ask questions in our group chat, so that probably your question would also be your classmate's question, then I can answer that question for everyone else. All right. Thank you, and see you in my next lecture.